Warm good evening to all. I welcome you all to week 10 live session for Advanced Concrete Technology NPTEL course. Let me share my screen now. I am Nilakanmani. I am one of the NPTEL TAs for the course NPTEL course Advanced Concrete Technology, and this is week 10 problem solving session. Am I audible to all? Can someone unmute and say whether I am audible?
Yes, audible, ma'am.
Okay, thank you. Since I can't stop sharing my screen, so please help me when I ask something. You can either even if I ask answer for the question, please be attentive in the class. Thank you. So in this week, particularly week 10, in the last class we have seen hardened properties of hardened concrete, and then how it can be how the toughness property can be enhanced with fiber reinforcement. And this week also we'll see some content from fiber reinforced concrete, and then we'll see the time dependent stress and strains in concrete, particularly creep and shrinkage, mainly due to the movement of water inside the concrete. Okay, so now let me now before getting into the problems, let me show a feature to you guys. I know if you have attended my class, and it should be evident for all. So to the bottom right corner of your screen, there is an option called activities. So if you click that, there will be option called, there will be 4 different options. Out of that, if you need to select polls. If you click polls, you can find the questions already launched here. Okay, so when we discuss a particular question, please give your answers in the polls. And if you are not able to find polls in your mobile phone, then there will be 3 dot in the screen. Okay, if you click that, in that you can find activities, and then from the activities you can go to polls. Okay, if in any way you're not able to find it, you can give your answer in chat box. Even if you have any query regarding the class, you can post it in the chat box. Okay, so and if in case if you find it difficult to follow, or else if you have any query, you can stop me by any time, and then you can ask your query. Okay, so thank you. Getting back to the PPT here, I hope you guys have already watched the video. Unless you watch the video, it will be difficult for you guys to understand the question we post here and then ask for answer. So I hope that you guys have already watched the video and come for the live session. Moving to the first question for week 10 content. So here is going to be true or false question. It's a very simple question which is related to last week as well. So the question here is flexural toughness performance of fiber reinforced concrete varies with the type of fiber used in the concrete. There are different types of fiber. Can someone say different types of fiber which is used in fiber reinforced concrete?
Steel fiber,
Yeah.
glass, polypropylene, and polyester.
Yeah, thank you. So there are different types of fibers which is used in concrete. So different types of fibers are used for its different particular property that we want to achieve from the specialized concrete, right? Fiber reinforced concrete. So here they are saying that flexural toughness performance of fiber reinforced concrete varies with the type of fiber used in the concrete. Is it so? Let me start the timer for a minute. Please give your answer. After a minute, we'll see the answer and discussion. So flexural toughness is nothing but once we get the stress strain response from stress strain response, we have to calculate the area under the curve. That is nothing but the flexural toughness we measure from fiber reinforced concrete. Time is up. Did you guys have given the answer? Okay, let me stop sharing the screen. And if you guys want me to put the question in chat box as well, please tell me. Okay, true. That's fine. Then pause. Okay, Most have selected true. Thank you. Now let's get back to the PPT. So since you guys all know, let's skip the explanation. Let me read it out as fast as possible. So here this particular graph shows the flexural toughness variation with the type of fibers used. This black one is nothing but the plain concrete. And then when it comes to different types of fibers, where if it's a steel fiber concrete, then its performance will be different from plain concrete. And then even with steel fiber also, if we add polypropylene, the toughness will be different. And then if you add steel with polyester, then its performance is going to be different, and similar with steel plus glass. So the flexural toughness measurement will also vary with the type of fiber we use in the concrete. Okay, so and out of it, steel has the better toughness performance compared to other type of fibers. Moving to question 2. The question 2 is the hooped fibers perform better than straight fibers of same length and shape. There is a statement, you have to find why. Because option A is hooped fibers provide more surface area of contact. The option B is only straight fibers form weak interface with concrete. And then option C is lot of energy is consumed in straightening the hooped fibers. And then option D is none of these. Let me start the timer for a minute. Please give your answers. So there are normally the fibers we get from market will be different. So if it's a straight fiber, then if you take a straight fiber and if it's a hooped fiber, the performance is going to differ. And hooped fibers are performing better compared to straight fibers. So you need to find why. Time is up. Let me stop sharing the screen. And if you want to still give the answer, you can just stop me by. And I hope you guys can give the answer because it's directly from the practicing problems. Let me end the poll for question 1. Okay, most of you have given the right answer. So come to chat box. Option C. That's fine. Okay, getting back to the PPT. So sir has clearly explained with the diagram, saying that the hooped fibers, there will be plastic deformation of the fiber hoop, particularly the curved portion, the hooped portion, bent portion. It will tend to straighten when the load tries to when we pull out the fiber. Okay, so the mechanism in the hook the way the hooked fibers behave is that in straightening the hooked fiber, there will be a lot of energy consumed. That's why hooked fibers perform better compared to straight fibers. So, and lot of energy is consumed in straightening the fiber. That's why we could see this particular peaks from the stress strain curve is can be related to the plastic deformation of the fiber hoop, which is bent. Now let's move to question 3. Question 3 is flexural toughness decreases with increase in fiber dosage. So I'll repeat the question. Flexural toughness decreases with increase in fiber dosage. You have to find whether it's true or false. It's a simple question. Let me start the timer now. I feel now the class has started. You guys have started following the video properly. I could find more correct answers compared to last few weeks. I could find more correct answers now. Time is up. Let me stop sharing. Okay. True. I think most of you have given the answer in polls, I guess. Okay. There is some mixed response. Okay. As I told, flexure toughness is nothing but the area under the stress strain response, the whole area under the curve till it fails. So obviously, flexure toughness will increase with the increase in fiber dosage, because normal concrete is brittle in nature. Okay, but when we add fibers to it, it gives ductile behavior to the concrete. It increases the ductility behavior. Okay, so the correct answer is false. Let me get back to the PPT. So it's direct. It's direct from the lecture actually. As the dosage of fibers increases, the flexural toughness increases. So here we can see this M40SF0. So you can see once the fiber dosage increases, see from 0 to 45%, you can see there is increase in the flexural toughness of the concrete, because the area under the curve is increasing. So that is the point I want to mention. Then let's move to next question. So question 4 is, steel fibers perform better than glass fibers for a particular volume fraction. Let me repeat the question again. Steel fibers perform better than glass fibers for a particular volume fraction. Please give your answers. Let me start the timer now. I think we have discussed about the same point last week. If you guys remember, you will get the correct answer. And if someone knew the correct reason of this question, you can post it in the chat box as well if you have time. If you find it's true, you have to tell it why. If you say it's false, you have to tell it why it's false. Time is up. Let me wait for some more seconds. Please type the reason if you know it. Okay, let's check the answer and pause until then. Okay, please give your explanation in the chat box. Let me read it later. Okay. Moving to question 4. Steel fibers perform better. Okay. Yeah, high tensile strength of steel, that is also right. Let me end the poll here and get back to the chat box. Yeah, that is one of the reasons. And then we can't say stronger. How we can say stronger? Maybe if you actually, glass fibers has more brittleness. Okay, so the point of adding fibers to the concrete is to move it from brittle to ductile behavior, right? So the purpose of adding fibers is to increase the ductility of the concrete. So steel fibers perform better when it comes to ductile behavior of concrete compared to glass fibers. Adding glass fibers increases the brittleness of the concrete. Okay, it might perform better compared to normal concrete, but overall it will add up to the brittleness of the concrete. Okay, because in the okay, change the pointer. So here in the same graph, we can find the steel fibers. You can see it's more ductile compared to the glass fibers, and also it is direct. This particular sentence is the statement is from the lecture actually. So the correct answer is true. Steel fibers perform better than glass fibers. So here is question 5. Is the assertion reasoning type of question. So I've just shortly mentioned assertion as A and the reasoning as R in the options. Okay. So assertion is creep and shrinkage or time dependent strains that involve the movement of water. I hope you guys knew it if you watched the lecture. Both creep and shrinkage are time dependent strains which involve the movement of water. And then the reasoning is R is these strains nothing but creep and shrinkage. Time dependent strains are completely recoverable when the load is removed or the concrete is resaturated. Okay, so let me start the timer now for a minute. Please read the question completely and give the answers properly. So here are the different options. You can pick the right one. So the first option is that both assertion reasoning A and R are true, and R is a proper reasoning of A. B is nothing but A and R is true, but R is not proper reasoning for A. And then C says A is true but R is false. D is A is false but R is true, and E is nothing but both A and R is false. Please go through the statements properly and then give your answer. And if you have any query, please stop me by any time and you can ask the query. And also finally, we might have some 5 to 10 minutes. If you have any query regarding the lecture, you can ask me. Time is up. Let me stop sharing. Is it okay? Or someone needs to give answer. Okay. Option C, option C. And someone has told me last time as steel is more stronger than glass. In what way it's stronger? By what property you're telling it? That you please mention that next time. Maybe
It's a tensile strength.
sorry.
Tensile strength of steel will be more than tensile strength of
Okay.
glass.
Okay, that is what you want to mention here. Okay, okay, okay. Let me get to polls. Okay, most of you have given the right answer, I guess. Okay, let me in the poll here. It was a very direct question from the lecture. So, getting back to the PPT. So, here it's clearly mentioned in the lecture that these strains are not completely recoverable because even there will be only elastic recovery and a creep recovery will be there once the load is removed, and then if the concrete gets resaturated there will be some elastic recovery from the shrinkage as well, but it is not completely recoverable. So moving to question 6. Question 6 is creep and shrinkage or time dependent test. So these include the movement of water that you guys already know. In creep strain, the water is lost or moved by stress, and the water gets uh, moved or lost during shrinkage. This is the question. So if you find option A is right, then you say that creep strain, the water is lost by stress and the water gets moved during shrinkage. If you pick option B, then it means the creep strain, in creep strain, the water is moved by stress and then the water gets lost during shrinkage. Okay. So let me start the timer for a minute. Time is up. Let me see the class response. Okay. Some mixed response is there. Okay. Both A and B is there. Can you explain the combined effect of shrinkage and creep? Okay. Actually, I have a question regarding this. So finally, we'll speak about that. Okay. Yeah, sure. So getting back to the PPT. So it's clearly mentioned in the lecture that shrinkage strains occur when water is lost and creep strains occur when water is forced to move by stress. So the correct answer is option B. It's not option E. Okay. In creep strain, the water is moved by stress and then the water gets lost during shrinkage. Going to question 7. Question 7 is, let me read out the question. Creep is a permanent deformation caused under sustained loading. Okay. And then here there are two subparts. So rearrangement of hydrate cement paste, particularly the layered products like CSH, is called what? Is drying creep or basic creep? Moving to part 2, expulsion of water is basic creep or drying creep. You have to find the correct option. If you pick option A, then you say the rearrangement of hydrated cement paste is drying creep and then expulsion of water is basic creep. And if you pick option B, then the rearrangement of hydrated cement paste will be basic creep and then expulsion of water is drying creep. Okay, so let me start the timer now. Please give your answer in polls, or if you're not able to find it, please give in the chat box. Time is up. Let me stop sharing the screen and see the class response. Okay, more option B. Let's see from the polls. Okay, again it's some mixed response here. Sorry, it's question 6, right? Let me in the poll here. Yeah. Okay, most have given the right answer. Let me in the poll here. So getting back to the PPT. And this question also direct from the lecture. So the lecture sir has clearly explained about what is creep and how does it occur. So creep is nothing but sustained loading causes creep, and then there will be rearrangement of hydrated cement paste, particularly CSH kind of layered hydration products with CSH, and there will be expulsion of water. So once there is rearrangement in the layers of hydration products, then the water in between can move out, right? The expulsion of water can also happen. So these result in a gradual change in volume, and creep can be listed as basic creep as well as drying creep. So basic creep is nothing but the rearrangement of CSH hydration products, and then drying creep is nothing but the expulsion of water. And most have given the right answer. Now let's move to question 8. So question 8 is direct from the practice assignment questions. So question 8 is joints with sealing materials or made on pavement slabs to reduce cracking due to drying. Okay, So they are giving joint with sealing materials or made on pavement slabs reduce cracking due to drying, and reasoning is the pavements are restrained by soil and and the tensile stresses are generated. Okay, so these are this is the assertion, this is the reasoning. So you have to find which is right and which is wrong. So if you find statement A is correct and R is incorrect, then you have to pick option A. Similarly, you can pick the please choose the correct option which you find is relevant and then correct. Let me start the timer now. Time is up. Let me stop sharing the screen and see the class response. So let me see it from polls. Okay. Most of you have picked the right answer, I guess. Let me in the poll here. Going to chat box. I think no one has given the answer in chat box, I guess. Okay. Getting back to PPT. So here they have mentioned that joints with sealing materials are made on pavements. Normally, if there is two pavement, there is a joint. We give sealing material in between the joint. So there is no. And normally, if it's a concrete pavement, we used to give steel extra steel reinforcement in the joints to withstand the cracking due to shrinkage, right? And then here the reason given is the pavements are restrained by soil and the tensile stress are generated. I have a question here. Okay, before getting to the answer, let me pose this question here in the chat box and please give your answers. What do you feel? And I'll explain the question as well. So assume you're in a paddy field. Okay, assume you are in a paddy field. Dry paddy field. Okay, yeah, where it has been harvested. It's a famous question by one of our professors. So just think and clearly give your answer. Okay. So what you'll generally observe in a paddy field? Can someone say? If you go to a paddy field which is harvested one and it's completely dry now, what will observe? Cracks. Yeah, right. So, and if there are, if it's completely an hypothetical situation, again I'll put assume. So assume that you have added, not you have added, okay, assume that there is a that oil or any lubricant is added to the soil oil or lubricant is added to the soil layer of 1 feet deep or less than 1 feet. Okay. Less than 1 feet. Will you observe cracks? This is a question. So, assume that in a dry paddy field, which is harvested one, so it's completely dry, and then assume that that a layer of oil or any lubricant is added to the soil. A total layer of oil or lubricant is added to the soil at 1 feet deep. Okay, beneath the paddy field. Okay, from the surface, 1 feet deep or less than a feet deep, we have added a layer of oil or lubricant. Will you really observe cracks? Let me start the timer now. Okay, someone have put no. Okay, nice, interesting. Why? Can Bharat Polusoni can type why? Yeah, Bharat Polusoni, it's right. Your answer is really correct. Can you tell me why? And even if you have some other different answers, you're free to share here. Let me start the timer now. After a minute, we'll get back to the solution of the actual question from the PPT. Let me wait for a minute. If someone else know the correct answer also, you can post it here. Why? Why will you not observe cracks? So what does the oil or the lubricant will provide you when if a dry paddy field without any lubricant, a layer of lubricant will crack and
I think soil may become viscous. What I feel,
okay.
soil may become viscous. That's why cracks may not be formed. Maybe this is just me. Because when oil is mixed with soil,
Okay, sir. I have one more question. Okay, take two. Assume a concrete cube. Okay, assume a concrete cube, and then okay. Let me stop the time. Assume a concrete cube, and then assume your assume a free concrete cube which is not restrained on any of the sides, and assume a concrete cube that is restrained and it is uh, put in between. Sorry, I could not explain it right now here. Okay, let me draw it here if possible. Okay, first I have to share my screen. No, then only I can use the pointer option. Yeah. Okay. Okay. So assume a concrete cube, free concrete cube. Okay, which is hinged from one side. So assume a concrete cube or any thing that is hinged on the both side. Which one you expect to crack and which one not? Let's assume one and then two. Please unmute and tell me which one you expect to crack. It's a concrete cube.
2.
Yeah.
Second one.
Second one. Why second one?
Ma'am, second one is restrained against any
Yeah.
movement.
Yeah. So here the restrainment is the major key. Okay. So whatever you said is not the correct answer. So let me get back to the solution. So no loss of moisture. No. Maybe if you add some oil, you think that no. That is not the correct. Why we don't seek. It's an imaginary question anyway, but we'll not see cracks as per the assumption conditions. So just like we apply crack heal, so okay. No, that's not the way. So here, when soils are at different layers, they will be restrained when the top layer shrinks. Look, because loss of moisture will happen only from the top soil layer. So okay. So but if you check the soil beneath 1 feet, you can find some moisture. So there is some reduction in the volume from the top layer, but the bottom will not shrink. So there is a restraint between the layers. That's why concrete cracks. So, but if you once you provide a layer of oil or lubricant overall, what happens is it's free to shrink. So there will be no cracks. It is shrunk, but there will be no cracks. So similar to the concrete cube as an example given here. If it's free to shrink, why there will be a crack? There will be no crack, right? Even if in a structure also, if there is some restraint to the given shrinkage, then only concrete cracks, or else concrete will not crack. Okay, so now let's move to next question. Sorry, you have to see the solution, right? So the correct answer is statement A and R are correct, and R is a proper reasoning to A, because there is some restraint by the soil. So because of that restrainment, there will be tensile stress generated. That's why we provide joint sealing material for the joints. Okay, so now moving to the next question. So here is also one more question. So this is also an assumption type of question. So assume there are two buildings. One is building A and building B. Okay, they both building A and building B are similar type of structure, constructed at the same time, same locality. Okay, and with similar type of loading. It's not that building A will be loaded too much and building A will not be loaded at all. No. And then building A was subjected to usage with only difference is that building A was subjected to usage within a month of construction, whereas building B was brought to use after 6 months of construction. Okay, only difference is that building A was subjected to usage within a month, and then building B was brought to use after 6 months of construction. Which building will experience a less creep? Okay, we are not going to measure just after a year of construction. Here we have mentioned it very clearly, measured 1 year after its occupancy. Okay, once it's occupied, it's under load, right? So if a building is loaded for a year, and then if you measure the stress, which will experience less creep, and then why? So in pose I've given you options. You can pick which will experience less creep, building A or building B, and then please type in the chat box why you feel either building A or building B will experience less creep. Okay, let me start a timer for 2 minutes. If you have watched the video, then it's a very easy answer. It's very direct. Just if you feel whatever is right or wrong, you can give your answers. That's fine. Then only we'll get to know how much we were able to exactly understand the situation, give the answers. One minute over. Even if you're free to type in the chat box, you can type which building will be having less creep, either it's building A or building B, and then just you can type the reason. That's also it's fine for me. Only 10 seconds more. Time is up. Let me stop sharing the screen. Okay. Just like if, okay, that's the old one. Okay, I think both buildings have same creep. Okay. Let's see the polls as well and then get back to the solution. Okay, someone have put that removal of water is easier in building A. Why? Yeah, building B is the right answer. You have typed the right answer, but why no discussion in the chat box? Someone had told me removal of water is easier in building A. Why? Why do you think so? Okay. Getting back to the PPT, as most of you said, building B will experience less creep because creep is highest at early ages of concrete since removal of moisture is easier. Because see, when you know that with increased period, with increased ages, the degree of hydration will be more. Okay, so there will be not much free water available for removal. But if since we know that building A was subject to usage within a month of construction, then the degree of hydration obviously will be lesser compared to building B in building A. So there will be more water available for the removal. So the removal of moisture is easier. Okay, so what you said is right, mainly because of the degree of hydration and particularly when it is subject to early ages, when it is subject to loading at early ages. And normally, even if the house is constructed within some period of time, we will not occupy the house for a certain period of time, right? You would have observed why the house is already built, why we should not subject to usage within a particular period of time. So they'll construct the building, they'll do some works, everything finished, then only they'll move to the building. Because how much time we wait to occupy the building, it will be strong enough because of this degree of hydration. Okay, and then it have better strength also with ages. Now let's move to question 10. Question 10 is under uniaxial loading, the elastic creep and shrinkage strains will lead to axial contraction, whereas shrinkage and creep may compensate each other in the lateral direction. Why? So we know that under uniaxial loading, the elastic creep and shrinkage strains will lead to axial contraction because of the loss of moisture. Okay, and then rearrangement of the hydrates as well. Whereas shrinkage and creep may compensate each other in the lateral direction, not in the longitudinal direction. I'm speaking about the lateral one. Because why? You have to pick the correct option. Let me start the timer now for a minute. So here there are 4 options already available. And someone have asked me to speak about the combined effect of creep and shrinkage, right? You have to pick the right answer. Let me read the options if you find it difficult. So shrinkage leads to lateral expansion, whereas creep is additive to elastic strain. Okay, then option B is creep is additive to elastic strain and lead to lateral expansion, whereas shrinkage is volumetric. And then option C is creep and shrinkage happen at the same time because both are volumetric. Option D is shrinkage leads to increase in elastic strain, which compensates the creep strain. I think today we can wind up the session earlier, if possible. Let's see. Because still we have only one more question. Okay. Time is up. Let's see the class response. Okay. Some mixed response here. Okay. Let me in the poll. And then getting back to the PPT. So here they are speaking about they've given the statement already. So both will lead to axial contraction, but whereas shrinkage and creep can compensate each other in the lateral direction. Because see, when it comes to when it comes to creep, it's just an additive to elastic strain. Whatever happens, like if you see the stress strain graph, it's just an addition to the elastic creep. Okay, elastic strain here. So but when it comes and they are speaking about uniaxial loading, not other type of loading. So when it comes to creep, there will be added to elastic strain, but when it comes to shrinkage, it's volumetric. Okay, it happens in all the directions. Okay, shrinkage will not happen only in the longitudinal direction, it will happen in all the direction. Let me use the pen to draw it, or else it will be difficult. So assuming that a uniaxial loading condition like this, if it's a structure, then uniaxial loading is assumed it to be a compression one. Okay, sorry for the poor diagram. So assume that the load is applied equally on both the sides. So here we knew that shrinkage can happen on all the sides, right? So it's not a 3D diagram, it's okay. So shrinkage will happen in all the direction, right? In this direction, x, y, z, all these directions, shrinkage will happen. But when it comes to creep, it will happen only in the direction of loading. So there will be deformation in the direction of loading. So it will lead to some expansion in the lateral direction. Okay, so because of that, in the lateral direction, there will be some deformation due to shrinkage, because it's volumetric, it will happen in all the direction. But when it comes to creep strains, the creep strain will be in this direction, in the vertical direction. Whatever happens in this direction, it will compensate the shrinkage strain. You guys got it right? Okay, let me draw it here again. So if it's let's assume only shrinkage. Okay, if it's shrinkage, then obviously there will be reduction in volume in all the sides, right? Like this. So obviously there will be reduction in volume. This much reduction will not be there, but to represent, I'm drawing like this. But when it comes to creep, there will be deformation only in the. Let me draw same cube. But when it comes to creep, there will be deformation only in the longitudinal direction, because it will be only in the direction of loading. Okay, if there is only compaction on this side, then obviously this side will bulge out, right? So already we have some shrinkage here, and concrete is bulging out here. So obviously this both will cancel out, right? Both will cancel out. So because of that, only shrinkage and creep will compensate each other in the lateral direction. Okay, the shrinkage will happen on all the sides, but creep will only happen in the direction of loading. Okay, now let's move to question 11. This is the last question. So last question is this: there is 3 statements here. You have to read all the 3 statements directly from the assignment practice assignment question. So the first statement is the shrinkage strain is higher in stage 1 and 2 than stage 0 to 1. Please refer to this diagram here. This y-axis is nothing but shrinkage strain, and the x-axis is nothing but the weight loss. So weight loss due to water, moisture loss to the environment. What is the weight loss and what is shrinkage strain? So here there are 2 stages of weight loss. Okay, so initially the weight loss is not much, but in the second stage there is much weight loss. Okay, but even though the weight loss here is pretty higher in 0 to 1, that is the first stage 0 to 1, but the shrinkage strain is not not much higher. But when it comes to stage 1 and 2, the weight loss is not that high. Okay, compared to the weight loss from 0 to 1, and compared with 1 and 2, the weight loss is higher in 0 to 1. But if we compare the shrinkage strain, obviously the shrinkage strain is higher in the portion 1 to 2. Okay, that is what explained in the statements. So here they are saying, let me go to pointer. The first statement A says that the shrinkage strain is higher in stage 1 and 2. Yeah, it's higher in 1 and 2. And then than stage 0 to 1 because of removal of water from the capillary pores in stage 0 to 1, and then gel pores in stage 1 to 2. Okay, so here in this diagram they have not told you about the pores, but you should know about the at what stage which from which pores water will be lost. Okay, removed due to shrinkage or due to shrinkage. Okay, and second statement R says that the amount of water removed in stage 1 to 2 is less than 0 to 1. It's pretty clear. And then third statement S says that the capillary pores are larger in size, leading to generation of less strain when dried, whereas the gel pores have absorbed or interlayer water corresponding to less loss of water and increases shrinkage strain. Okay, so these are the three statements. Let me start the timer now for 1.5 minutes. Please give your answer. Time is up. Okay, let me stop sharing the screen and see the class response. Okay, most of you I think found that all the statements are correct, but you could not easily found out which is the proper reasoning. Either it's R is the proper reasoning for A and S, and whether S is the proper reasoning for A and R. Okay, let me see the chat box once. If you have any other query, please post it in the chat box. Someone have asked about explain the uh, effect of creep and shrinkage. If you have any specific question regarding the topic, please post it. I don't know who's that. Yeah, Shwetan Kumar. Okay, Shwetan Kumar, if you have any specific question regarding that thing, I can answer your question. Or else I don't know what, in what way you're asking. I didn't get it. Okay, so now let me get back to the PPT. I think most of you know the answer. Let me show it here. So all these statements are correct, but S is the proper reasoning of A and R, because we know that the amount of water removal in stage 1 and 2 is less than stage 0 to 1. That we know it easily from the graph itself. And then also shrinkage strain is less in stage 0 to 1 compared to 1 to 2. That is also clearly evident from the diagram. And they are saying that the removal of water from capillary pores is from 0 to 1, and then gel pores is from stage 1 and 2. That is also correct, because capillary pores are bigger in size. It's easy for the moisture water from the capillary pores to easily dry out compared to the gel pores, because they're very fine pores. It's difficult for the water and the very fine pores to dry out. And then here in the statement as they're saying that the capillary pores are larger in size, leading to generation of less strain when dry, whereas the gel pores have absorbed or interlayer water corresponding to the less loss of water and then increased shrinkage strain, because it's very fine pores. Drying out of water from the very fine pores will cause uh, uh, higher amount of strain compared to the water drying out from the capillary pores. So that's why even though the weight loss is pretty higher in the stage 0 to 1, it has led to very less amount of shrinkage strain compared to the stage 1 to 2. Okay, so this is the reason. I hope you guys got it right and you guys were already giving correct answers today. I'm really happy, and then you guys are open for discussion as well. Thank you. So this is the last question for this week. Any other questions? Shwetan, do you have any particular query regarding the topic? What do you want to know?
Yes, ma'am.
Yeah, what is your query?
Ma'am, sir told like the it both will compensate each other for the stress development in a column.
Yeah,
So how will that how will the compensation will happen? That
okay,
I
let me
didn't
get
understand.
back to the same. I think we have talked
Yes,
about here. See, it's just whatever because I don't want to open it because this question is just similar to the query what you asked. So assume this to be a column. Okay, let's draw it little bit larger. Okay, assume it to be a column, the same column. Let's try to uh, let me change the. Is it possible to change the pen color? Let me take blue color. Okay, so uh, assume that this is a column, actual column. Let's try to assume what is the effect of shrinkage and then creep separately. Okay, this is going to be shrinkage. Okay, sorry, here it's not going to work. Let's take green and then we write it as shrinkage. This one is for the creep. So one is for shrinkage and two is for creep. Okay, let me write it as 1 and 2 here. Change the color as well. Okay, so here what will happen if a concrete shrinkage, if it shrinks? It will shrink from all the direction, right? So overall there will be some reduction in the size of the column depending upon the type of cement. So I'm assuming it on the all direction reduces. So similar to this one. Okay. But when it comes to creep, see, normally column will be loaded like this. If it's not, there is no any eccentrical loading, it will be compression will be acting in column. So what will happen to column if there is some compression load on the top and bottom? What will happen? There will be some reduction in there will be some deformation, right? So there will be some reduction in its height, right? Very minute reduction will be there. So the height will be reduced to this much extent, right? And then
yes,
if there is some reduction in its height, what will happen? The alternate size, obviously there's some increase in its lateral direction, right? As I said it here. So what will happen? There is some shrinkage in the lateral direction due to shrinkage. In all the sides there will be shrinkage, but when it comes to lateral direction shrinkage, there will be reduction in its size. But when it comes to creep, in the lateral direction there will be increase in the dimensions of the column. So obviously what will happen if there is a decrease and there is an increase, it will compensate each other, right?
yes, ma'am.
That's what I was trying to explain here.
Okay.
Yeah, I hope you got it right. Any other
And
query?
ma'am,
Yeah.
yes, ma'am. Like when we use mineral admixture like microsilica,
Yeah.
then there will be more creep and shrinkage. So so like so should we while mixing the concrete should the water content be increased during the mixing itself?
You're saying that a very fine and then reactive SEMs. Let me stop presenting now. So you're speaking about highly reactive pozzolanic material, right?
Yes, ma'am.
Okay. Shwetan, if you're adding, particularly when it comes to silica fume, it's a highly reactive material and it's very fine as well. When the fine content in the cement concrete increases, the amount of shrinkage will be very high because the amount of reacting material is also high. So the shrinkage also will be very high. And what you ask is, can we increase the amount of water while mixing so that we can compensate for the shrinkage, right?
Yes, ma'am.
Yeah. Shwetank, if you increase the amount of water, the excess amount of water will go out of the concrete after some period of time, right? Only a certain amount of water is required for a complete degree of hydration, right?
Yes.
Whatever water is available excess in the concrete will go out at any point of time after some years or some time from the concrete. So that loss of moisture. So there are different types of shrinkage in concrete. Okay, when it comes to cement concrete, one is drying shrinkage. When there is a loss of moisture from the concrete, it's called drying shrinkage. And if the shrinkage happens due to movement of water from hydrated phase to unhydrated phase. If there is if there's a concrete cube, assume if this is a concrete cube and this part it's hydrated, but
Yes.
this part is not hydrated, so water will move from here to here. This movement of water from hydrated phase to unhydrated phase will cause some strains. The movement of water through very minute pores will cause some strain that will lead to shrinkage. Okay,
Oh,
so if it's a very low water to cement ratio concrete, obviously your autogenous shrinkage will be higher. If it's a high water to cement ratio system, then your drying shrinkage will be higher. But
okay.
normally, a typical concrete system, the extent of autogenous shrinkage will be lesser compared to your drying shrinkage. But if it's assume a high strength concrete, if the water to cement ratio lies in the range of 0.2 to 0.3, then obviously autogenous shrinkage will be higher.
Yes.
Yeah. So increasing or decreasing the water will not directly reflect on shrinkage. To be frank, if you increase the amount of water, obviously shrinkage will increase. To say it plainly,
Yes.
without any factor.
Yes. Yes, ma'am. But the drying shrinkage will increase when the
Yeah,
water cement ratio is
yeah, yeah.
okay.
Did you?
So how is the
Is your query
balance?
clarified?
Yes, ma'am. So how is the balance maintained while mixing?
Okay. So if you add silica fume, it's better to not. Normally, when we go for high strength concrete, I have not worked in field, so I am not the correct person to answer the question. I have not worked with silica fume as well. But normally, when it comes to high strength concrete, if you're laying it for floorings and all, obviously the rate of loss of moisture to the environment will be higher, right? Assume a
Yes.
metro construction where the amount of concrete on the like laid on the bridges, it is exposed much to the environment, right? So there will be much loss of moisture as well. So in such cases, it's better to use shrinkage reducing admixtures. So what happens is with shrinkage reducing admixtures, so because the water passes through the from hydrated phase to unhydrated phase, there is, because it passes through very fine pores through the meniscus, because of the meniscus there is increase in the autogenous shrinkage. So if you add shrinkage reducing admixtures, it just changes the property of the pore walls. Okay, so because of that, the traveling of water to the minute pores will not cause much strain to the concrete.
Oh,
And also we can use fiber reinforced concrete for floors where you use silica fume. In such cases, it will help you with bridging the cracks.
okay.
These are the solutions that we can think about, and and also when concrete is plastic, it's still green. It's better to cover and reduce the rate of evaporation rate from the concrete as well. We can provide some windshields. That is possible to do. And then apart from that, we can, once its concrete is set, we can start curing immediately.
Yes.
Yeah.
Okay. Got
Yeah. Okay then. I think let me see the. Okay, I don't think still you guys have any query. If you have any query, you can be in the class, or else we can wind up the class. Thank you all. Thank you for being active today. Okay, let me wind up the class.